forgot to record that part. Okay, well, now it's recording. All right, so again, just for the recording purposes, like I said, what we're focusing on is mostly integration testing. So if I have a situation like this path over here, nodes 1, 2, 3, 4, I have a definition of x in the first two node and a use of x of the variable and in the last two nodes 3 and 4. I really care mostly about the last definition and the first use. So I care about the du pair of the variable x that's happening between nodes 2 and 3. Okay. Node 1, 3, and 1, 4 themselves are not actually du pairs to begin with because it's not a def clear path. At the same time, node 2, 4, it is a du pair, but it's not one we care about because it's not really the first use, so it's not really testing the connection between the two different objects. One you see in the yellow, and the other one also you see in the other yellow. So we're focusing mostly of the connection between nodes 2 and 3, and the last time the variable x was defined in 2, and the last time it was defined in 3. So it was, and the first time it was defined in 3. But note that although it's really the same variable, it could have changed names, and we need to be able to track that, okay? And because it's difficult to keep track and do sort of things, we don't want to be doing it across so many different methods within the same class, okay? So, to go back here again, if I have an object over here and an object over there, okay, I have a variable x, and the variable x keeps being called from one function to the next. All of this, I don't really care about at all. Okay, and it changes from x to y and y to z and z to a and a to b, and all this work is something that to me is just a lot of hoopla for nothing, and it's not really taking care of integration testing, and it's something that we've already taken care of when we were just doing data flow analysis anyways, okay? Same thing with the other object. What I really cared about is the one that it got called somewhere, it got defined somewhere, and it got transferred to a different object altogether and went somewhere else, okay? So this is where integration testing occurs, all right? And now with this, there's a whole bunch of definitions. Yes. Let me just make sure I share the screen properly. Is it this one or is it this one? Okay. And now with where did it go? I think I closed it by mistake. Let me just make sure I share the screen. What slide were we? Can you remember? Okay, I found it. Okay. There we go. So and now we're going to look at a whole bunch of definitions as it arises with integration testing. So the definitions are pretty easy and pretty straightforward, but you gotta remember them and not confuse them with each other. The first of which is what a caller, and a caller is the unit that invokes another one. A callee is a unit that is being called. So far, so good. A call site is the statement in the caller node that, or the caller unit, that actually the call happens. The actual parameter is the variable as it's called and named in the caller unit, and the formal parameter is the variable name as it's called in the callee unit. Okay, so let's take a look at this over here. So this is two different objects. Okay, I'm gonna split them over here. So A is my caller, B is when I make a call to, sorry, the second one is where I make the call to the object B. So that's where I say this is my call site. X is the variable that's being transformed, and as it's being called in the caller unit, this is what it's called as an actual parameter. Object B with the function B. This is what I call the callee. X, which can later on get transformed into Y, is what we call a formal parameter, right? That place between the call site and the beginning of the method where the call is being executed at the callee unit, this is what we call the interface. Okay, in other words, this transfer of control flow from this line to that line, that's where the integration testing actually happened. Yes, obviously this could have happened within the same class, but we're looking for that this would be some sort of an object, and this is a different object. This is object 1, and this is object 2, in order to qualify as integration testing. All right. So applying data flow criteria to diffuse pairs between units is too expensive. There's too many possibilities, but this is integration testing. So we really care about that interface. Okay. And it's just basically reusing what we were saying before. All right. And that gives us rise to two definitions, which I've just explained a few moments ago. The first of which, the meaning of something that is called a last def. So a last def is a definition of a particular variable where it stays def clear until it goes out to the callee unit. Okay, because point basically, if it's got redefined again, then what's the point over here of focusing on that initial definition? Okay, and then the first use, which I've also explained before, and this is the first time that variable x, after it got transferred to the callee unit, got used at the callee unit, and this is where the integration testing happens. This is where the actual interface is, and this is what we care about the most. Otherwise, the name changes between the different classes within the same class is not really of that much importance to us. Okay, we'll just resort back to our old DU analysis that we've been doing before. So here's an example. Okay, I have a caller and a callee. Okay. In the caller, variable x got last defined when it was 14, and then there's a call site to the function g in the callee unit in the second line. So this is the call site. X then becomes a. So x is what we call the actual parameter, and a is what we call the formal parameter. Okay, so once I get to function a, to function g, and then I executed the function print a, this is where I'm actually using the value of a. All right. Another example, I have a variable called b, and this is where the last time it was defined. I returned it. So a return really is another function called, or should I say, a return of an execution flow between one object to the next. Okay, and then it goes back over here upstairs, and variable b got used as y for the first time after it came back. Okay, so let me actually draw this better. So it returns b, so b becomes y. Okay, and then the first time it got used over there in y. Okay, and again, I want to just pause here for a moment. Yes, this current. Going back to the whiteboard. So if you just bear with me for a second. And make sure I share the screen. if I have an object as such, okay, and another object over here, okay, I have a function is f2, f1, okay, and at some point I made a call for f2 with a variable called a, okay. This is what we call the call site, okay. Now, first thing you see is it's gonna be a definition here, so not a definition, a signature where a becomes b, okay. This is line, say 20 here, and this is line 54 in the code, okay. Now 20 to 54 is not a last def first use situation, okay. The fact that we have received it at the function signature means nothing, and it's only when b is actually used in here that there is some sort of a first use, okay. So this would be the first use over here. Now, if that didn't happen for some reason, let's just say we go like this, and we have a closing, and then we do a return, and in the middle, for some reason, variable b never got used, then again, there is no last def first use thing happening. A lot of students fall for that, okay. They look at the function and they see there's nothing where b is used, so then they say, well, line 54 is where the actual first use happened. No, okay, if you think about it, a have done a trip over here and come back again without it being used at all, okay. So we really, it doesn't come into our considerations when we're doing integration testing, because it never actually, yes, it got transferred, but it never got used. And if it never gets used, there's no situation that it can expose a default, expose a bug for us, a fault, I mean, not a default, okay. So that's important for us to know, okay. Even if the return itself said b as such, but again, there was no real use of b in the middle, that's still not a last def first use situation. All it is I gave function 2 variable a, it did nothing with it, and returned it back to me. Again, I'm not using it, okay. So line, what's the message, for example, 58 over here, again, 20 to 58 is not a last def first use situation. We don't really care about it, okay. This is a very common mistake students tend to fall into, all right, and I'm going to try to trip you in the exam, so be aware of this, okay. Another common situation over here, we see sometimes something as such, okay, and it says int x. That doesn't count as a definition. That doesn't count, and we didn't actually define, we declared a variable, we didn't define it, okay. It's only when I have something like as such and so x equals 5, or even a declaration with a definition, then I can call this a definition. Otherwise, it's not a definition, okay. And although I've explained this a few times already, but if that variable x gets used, defined in one function, and gets used in a different function within the same class, again, we don't care. So this is line, say, 24, this is line 28. 24 to 28 is not a last def first use situation. Why? Because it's happening within the same class, within the same object. So I don't really care about it. I don't really care about it, okay? So we don't define those as a last def. So it's not gonna be something that I'm gonna take into my account when I'm doing my integration testing. Right, back again to here. Okay, so we looked at this, the definition. So X is being used at print A. Now, print is not the name of the second function at the callee. The second function callee name is actually G. Okay. And it's only when the value of A got used with function print, then we've called this, we've declared this as a first use. Okay. As you notice over here, the function signature for G, it has received the variable A, but it's not actually using it. Receiving, just the fact that I'm receiving it is not in itself using it. Okay. Oh, and another thing, a return itself is not a use. It's kind of just like I'm returning back a variable. I'm not really using it per se. Okay. It's for the purpose of mainly returning the control flow of uh, um, of a function. Okay. So when it says b equals 42, that's my actual last definition. Okay. And the return b is not a use of b. Otherwise, we would never have had, if return b was in itself a use, we would never have integration testing happening. Right? It's another situation, b going back to the callee, the caller, which now becomes the callee, and being used again with the print function again, and the name being y. Okay. This is the actual, this would be the actual control flow graphs. All right. Again, that's a different example over here. All right. So at the bottom here, when B is actually being called, okay, from the call site, it goes to a different unit somewhere else in line, say number 10 or whatever. All right. And now X changes to Y. And in this situation, okay, I have X could have been defined in two different places, because the one that is actually being used over here could have come from node 2 or could have come from node 3. And then when it got received over there, it could have first used in node number 11, or could have been first used in node number 12. So really, I have a situation where I have node 2 and 3, and where it could be reused in 12 and 11 and 12. And I have a 2x2 situation as such. And what's the last one? And this is a very common situation as well. Okay, is this clear, that last point? Now, what I'm trying to say is, you seldom see it as in we had in this exercise over here, where there's only one place that I can say, well, this is the last place it got defined. It could have been defined in multiple places. I mean, this over here is nothing but probably an if-else statement. Could have been a switch, and the switch could have had 6 different branches. So that's 6 different places where it could have been last defined and sent out by node number 4. And again, as I come back over here, and I got the variable y, which is x previously, and what's happening over here is another if else. Again, it could have been a long if else chain, could have been a switch statement. All right. And I could have had 6 branches. Okay. And had I had a switch statement with 6 branches and another switch statement with 6 branches, that is a 6 multiplied by 6 situation, DU pairs. Okay. In the exam, you get some code and you feel inclined to keep writing a lot of DU pairs that qualify as last defs first uses, but the tricks, they don't qualify. Okay. So I'm going to put variable declaration with no definition, and I'm going to see if you fall for that. Maybe I'll send out a variable that got redefined somewhere else. Okay, so that's another trick that I can use. Okay, what I'm trying to say is, Let me clear this. Microsoft Whiteboard. So if this is my first class, this is my second class. I mean, let's just say I have the situation, and I'm going to call function 2 over here. Going to send it variable A, so it goes over there. But then immediately as I get over here, I go and I say something like this. Yes, I've received A from the other function, but really that last def that I received it was absolutely meaningless. Okay, so had I had a line over here, A equals 3, okay, that variable, that value 3 is completely meaningless over here. Okay, we never get to try out A as it's being equal to 3 in function 2, because as soon as I arrive, boom, this happens. Okay, so if there's a use for A over here, as we're going as such, it's not a def clear path. Okay, so if I go back to this little slide that I had, this little graph that I had, I have 1 going to 2, going to 3, and going to then 4. And I said I had a def for X over here, and I had a def for X over there, okay, followed by a use for X, okay. But this is how the objects were actually structured. This is one object, this is the second object, okay. And although this over here is where the integration testing is happening, this over here is not a last definition first use situation. Matter of fact, this over here is not even a DU path to begin with, because it's not even def clear to begin with. Okay, and again, this is a common trick. I warned you, gonna see it in the exam, so don't fall for it. Okay, this is really checking to know if you really know what you're doing, or you're just matching things together and hoping the more that I put in there, you know, the better my situation is. So it's not like prime path analysis where if you call up prime coverage, if you put in another an additional path, then I'm, you know, maybe let it slide. This one I don't let it slide. Okay, because the difference between you understanding and you completely not understanding what the heck you're doing. Okay, calls in between like this, that calls for mark deductions. Okay, because we're not doing unit testing, we're doing integration testing. Okay. Yes, I'm sorry. I keep forgetting this. I'm still good on time. So next slide. Okay. Now, we're gonna do integration testing here and this program. And assuming we have the following, okay, this is a unit, this over here, and it's continuing on over here, and then over there is a different unit, okay. We have two shared variables, root 1 and root 2, okay, that's going to be shared amongst the two units, okay. To begin with, we start off by computing x, y, and z over there. Could have been defined last over here, or could have been defined last over there. So we have a situation, oh, sorry. Could have had a situation where between the two different units, okay, this is one place that it could have defined, it's a different place that could have been defined, and it's going and it's crossing, all right? And over on the other side, x, y, and z going to be retrieved as a, b, and c, all right? This would have been the place, this line 38, this is a long line just spread over two lines, is where they first get used, okay? But after they first get used, so this, if this is node number 3, okay, after they first get used, all right, then we define a new variable, which we could have defined it at this node over here, the variable result, or we could have defined it at this node over here, along with root 1, and root 2. Okay, so it's a lot of code, but if you actually dissect the integration parts, it's not as much. Okay, so again, continuing on with, let me clear the screen so that you can actually see better. Continuing on over here, so this is another situation where, so this is node 1 and this is node 2. Okay. This is the call site, and then it's returning back over here visually. Okay, and we have another situation with the variable result. Could have defined in 2 different places before it comes back. So it could have come back from here, it could have come back from there. Okay, and then after it got over here, we actually check it in an if statement. Okay, and if it's true, then the roots where it got defined over here, we call this node 4. It's going to be used over here in node number 5. Okay, and yeah, those are the different last defs du pairs. Okay, now one thing probably I've missed to say before I get to this, I should have actually focused on that. Okay, this over here is considered a use. Okay, why? Because in order to evaluate the condition, I need to look at the variable name, at the variable value. Okay, just like I have an assignment, okay, like this, that means I'm using X, sorry, I'm using B. Okay. This over here means I'm also using B. I need to know its value. Okay, if it's 5, then I'm gonna go true. If it's 10, then I'm gonna go false. So I need to use this value. So this qualifies as a use, just like this one qualifies as a use as well. Okay. Is another trick. Two things happening at the same time, but which one actually is happening first? Okay, there's a definition of X, and then there's a use of X. Okay, so in this situation, okay, use of X. So X is actually increased by 1. So otherwise, I need to use it, and then I redefine a new value for X. Okay, whereas plus X would have been the opposite. I define it, then, okay, good. All right, so now looking at this particular code, again, we're just going to show it over 2 slides. All right, I have my shared variables. This is a situation for X, Y, and Z, 2 places where they could have been last defined. So 15, 16, 17, let's just call this node number 1, and those last 3, node number 2, as they get transferred to the second function through the function call that is hidden from the screen over here, A, B, and C. This is the first places where it got used. Okay, so this is line 38, and over there was lines 15, 16, 17. We'll call it 1 and 2. Okay, so 1 could have been coming over here, and 2, we have 2 situations over there. All right, so we're removing that now. After we've used them, A, B, and C, we've defined a variable D, and again, with D, we're going to use it over there. Fine, good. And then we've defined a variable called result, and then we returned it. So actually, we didn't really touch over here, but this is one situation. It was line 41, where result turns into OK at the top to be used in the if statement. Okay, so we have a 41 to 26 situation. Okay, and another situation, if this turns out to be a false, okay, then result gets defined in 46 instead. And so it would have been a 46 to back again to 26 situation where it gets reused again, okay? So 46, 41, or 46, two places where a last definition can happen, and one place where they could have been used, okay? Finally, in the case where this was true, all right, we have a situation over here where I'm just going to call those two nodes node number 3, where I defined root 1 and root 2, all right? And obviously it needed this if to be false, but we don't really care about this. And when we go back up, okay, I see we're not going to use them. Oh, sorry, we do use them over here. We're not going to use them if it was false, but we're going to use them if it was true. All right. So a situation where we go, and I'm going to call this is what, node number 27. Okay. 37. Sorry, node number 3 to 27 over here. All right. Despite it may not actually happen, in case this was false, okay, or in case this was true, still there is a path to it. So, and this is what we care about the most, okay? And when I actually get to do the testing, I will be sure to choose values to make this one over here become a false and this one over here become a true, in order to make sure that this 3 to 27 situation is actually happening. All right. And all I have to do then at this point is list them down. Okay. And this is how I list the couplings of the DU pairs. Okay. I say the name of the function, the variable name, the line it was last defined at, and the name of the new function, its name. Okay. X is going to be turned into an A, and then the line where it got used at. And as you can see, okay, remember we had the situation where we had the definitions. If you remember this, that over here, two different definitions, 1 and 2, going to be used in this line over here, 38. So 15, 16, 17, this is first situation 1, 21, 22, 23, that would be, oops, 2, to be used with 38, and this one to be used with 38 as well. Okay, same deal at the bottom over here. We just have to be able to track them down. It's not really that difficult of an exercise. Okay. Well, count them. We got 6 over here and 4, that'd be 10. Yeah. Yeah. I mean, assume X line 15, 16, 17. It was just actually like the one variable and it wasn't 16. So you will see the number of DU paths reduce rather considerably. But you know, this is the situation that is. But yes, it's a different DU path. So although it's almost the same node, 15, 16, and 17, still 15 to 38 is a DU path. This is a DU path, and this is a DU path. Okay. Even if for some reason this was 15, I mean, for somehow X and Y both got defined in the same line, still 15 to 18 is one DU path with respect to Y, and 15 to 38 is that those the same nodes, still considered a different DU path because it's with respect to a different variable. Okay. Everything good? Everything clear? Want to test out your skills? All right. I'm seeing a big resounding yes. Let me look at the chat. Yes, everybody's saying yes, yes, doctor, please give us an exercise. We really need one. Thank you very much, doctor. Yes. All right. Ask and you shall receive. You're looking at the chat. It's like nobody's. All right. So open up your Moodles. Oh, you actually don't have to open up your Moodles. Let me see if I can just, every time I say this, like we're back in the old days. Let me see. I probably just have the exercise over here. Not homeworks. Okay, there you go. So I'm glad we didn't actually need to. Let me just zoom in a little bit more. Beautiful. Okay, now make sure I share the screen. All right, so in this situation where we have two different function. One is called trash, another one is called takeout. Takeout, you see it on the right-hand side of the screen. Trash, you see it on the left-hand side of the screen. There's variables all left, right, and center. M and N and trash, D and E, and B, and takeout. Okay. We also have the variable O in trash. So what I need you to do is, as you look at this, I'm going to give you a table like this, and I ask you to write down a variable name, all right, where it got last defined, and then where it got first used. Okay. So that's the exercise. That's again another midterm question exam for you to that I brought before. I think it was 2 years ago. Beautiful, gorgeous exam. You see it bigger? Oh, it's not showing? Oh, yeah, okay. So I probably need to decrease the size شوية. Maybe make it 190. Yeah, that's good. The variable of x, a, and b. Okay. This over here, okay, we care about last definition, first use. Okay. Then when they're being written in the function signature, they're neither being defined and they're neither being used. Okay. Although in theory, you can actually define a variable in the signature, but that's not the case over here. Okay. I just said int a. I'm not using it. I'm not defining it either. That's what, sorry? Last definition first used between the different methods. Assuming there's different objects. Yeah, what? Yeah, not internal. If it's within the same function, then it's not integration testing. We don't really care about.
It's used in another class. Of, the line of execution is in the first class. Why count as it's being used in the first or the second?
Okay, so what are you talking about specifically?
Line 12.
Line 12, okay.
If I mention the
So M and M are being transferred to function takeout. What? Okay. So what we care about is M and M. So this is the call site. I care about where did M and M got last defined. It's gonna find them over here. Okay. And then where M and M, which now become A and B, got first used in here. Okay. I don't care about this part over there. That part over here, and this actual use that you see at the bottom, is the work that is done over here. So they do all the work, and then at the end they do a return to be used over there. Okay, and that in itself is not a use. Okay, that in itself, and all I'm doing is I'm just returning the value over there rather than actually using it. Okay.
we get every possible use, or do I just go for one use case?
What we care about is the first uses. Okay. Now it's good to realize what are all the uses, but what we really care about, I mean, when you're tracking down the codes, so M and M goes over here to A and B. You look at the first, so over here, not in this line, 19. A is always going to be used here. So how is, there's no point of actually checking the rest of the code for A. Okay. B, well, right now it's a little bit trickier because there's an if else statement. It could have happened over here, it could have happened over here. So it's a multiply by 2 situation. Okay. Um, yeah.
Eight possibilities.
Hmm?
8 possibilities.
Well, I can't remember exactly. I think you're right. Call you pairs. You bet. Okay, so let me check, guys at home. How many did you get? Why is it not opening the chat?
Could be open.
Yes, what could be? Nope. For some reason, it's not actually opening the chat. Okay, you have to say it, whoever just wrote, so I can't see the comment. So just say it on the microphone.
I got 8%.
You got 8 too? Who's that, Faye? Is that Faye? Oh, or Banan?
It's been on.
Banan, okay. So let's see. So, again, we have, let me just solve it. So we got M and N over here. Obviously, 1 and 3 doesn't mean anything, okay? We have 5, and this is line 5, where it could have been defined, but it could have actually been overwritten in line 7. So for M, I have 5 and 7, okay? And for N, I gotta have 9 and 11. So for M, 5 and 7, last uses, last definitions. And for N, 9 and 11, last definition to be sent out to take out. And now M becomes A, which we said is gonna be first used in line 19. So for M and A, it's 7, 19, 9, 19. Okay. Everybody follow me on this? All right. And for N, which is now B, we have a 2 by 2 situation. So it last defined 9 and 11, and it could have been first used in 21 and 22. So we're going to have 9, 21, 9, 23, followed by 11, 21, 11, 23. Okay. Finally, we have the variable E here that gets sent back. Variable E could have been last defined in 21 or 23 to be used in line number 13. Now, so we have 21 to 13, and then we have 23 to 13, and yes, that would be 8. Correct. Okay. Just to clear out a little thing over here, this over here, line 12, usually a source of confusion because we see an assignment next to it. That's the result of an entire function. Okay, so we're using an entire function, not applicable to us here. It's different from something like, say, line 19, where I'm actually directly using the value of a variable. Okay, so a result of a function is different than a result of a variable. Okay. All right, so this is why we don't count line 12 as a first use. Okay, because what we see on the right-hand side is an evaluation of a function. Whereas something like, say, in line 19 or even line 23, we're picking directly the value of a particular variable, and so we can trace it from one place to another one. Okay, that exercise is posted on Moodle, but I will be posting the solution for the exercise, inshallah, right after this lecture. Okay, so that's gonna be it for today. How about quiz on Wednesday? Sounds good. Next Monday? Carlos, next Monday. I can't hear you guys at home, but next Monday, okay with everyone? Should be. I'm pretty sure exams are done by now. So yeah, like quizzes 3 and 4 coming your way on Monday. Hey?
What time is it?
One exercise control flow graph. One exercise is what's it called? DU path analysis. Okay, data flow coverage. I mean, okay, where we're doing the DU path and first all depths, all uses, all DU pairs, fun stuff. Huh? Guys at home, any questions? I need you to say it because I can't see the chat for some reason. Any questions at home? Questions. All right. So I'm not hearing anybody. I'm assuming that everybody's okay. I will see you inshallah on Wednesday.